this is the last section where we talk about strict permutations. We'll talk about another pretty much a special kind of permutation in our next section. But we'll talk about permutations with repetitions. So number of permutations of how many objects you have, where you actually have identical objects or anything that looks the exact same, is actually given by this formula. So it's n factorial over a factorial, b factorial, c factorial, however many times something is repeated. So those things are things that are repeated or identical. So it's best to see in an example. So for example, Saskatoon has 9 letters, which is the total amount of objects that we're going to arrange. 9 factorial. Divided by the A, B, and C are just whatever object is being repeated. So for example, there are 2 S's. So the S's, there are 2. The A's, there's also 2. So 2 factorial. There's also 2 O's. So n factorial divided by 2 factorial, 2 factorial, 2 factorial is actually the answer. Just whenever you put it in, definitely put in brackets. I encourage to put brackets around the numerator too, but it's not necessary, especially if you only have one thing. Either way, 9 factorial, again, you access that factorial by pressing your PRB, divided by 2 factorial, 2 factorial, 2 factorial. If I type it into my calculator correctly, it should be 45,360. Now, if we go into more things like it, what about the word Canada? How many ways can all the letters of Canada be arranged? Well, that's really easy. We have 6 identical objects. Oh, sorry, I forgot to say that there's 2 O's. But there are 3 A's. So 6 factorial divided by 3 factorial. And 6 factorial divided by 3 factorial should be 120. I'm doing my head math right. I'm just going to double check that. Yep. Now, what about if the C and N needed to be the first and last place respectively? So we have a C, 4 letters, and then the N. Well, we have 4 letters left. We have the A, D, and an A. So we still have 3 A's. So this entire part in the middle here would just be all 4 letters left, the 3 A's and the D, divided by the fact that there are still 3 A's. If you type 4 factorial divided by 3 factorial in the calculator, there's 4. And we can actually list exactly what those are because there's only 4 options. So we could have it as, let's see, we'll put the C's in the first spot. I know that there's only going to be 4. We're going to have the A, B, A. And then we have N's. Because that's just what would be left. Of course, we can obviously adjust it. It could be 3 A's and then the D. It could be A, D, A. Sorry, just A. Or we could go da. That would be all 4 ways that these letters could be arranged. If the C and the N can only be in these 2. If the question said if the C and N had to be in the first and last position, without that respectively part, it could be, that would mean that we could also have the N there and the C there, which would just double the amount of things that we have. So we just have 2, basically we'd have 2 options for each of these. So it'd actually be 2, then we have 1 option, then we have the 4 factorial over 3 factorial. So 2 times 4 factorial over 3 factorial would come out as 8. But that's kind of a extension on that. This example actually talks about going exclusively into the next section, but it's works out beautifully as a permutation as well, especially with these repeating objects. So I'm just going to make a note that this is really a tie-in question to what the next section is going to talk about. We have 9 blocks, and you have to go 4 blocks north and 5 blocks east. So if we made it here, show you with an actual grid on here. Two, three. This would mean that we'd have to go in that option. So having to go 4 blocks north and 5 blocks east, that means that we'd have to start there and end there. 4 blocks north, which means 1, 2, 3, 4. And then 5 blocks east, 1, 2, 3, 4, 5. But if we can only go north, it should say only going north and east. So I'll have to fix up that terminology just slightly. It doesn't matter whether we go up one up here and then we go east and then we go all the way up and over, or we go over here, up, over, up, over, up. Those are completely different paths. But no matter what, the calculation for it is the same. We have a total of 9 blocks that we have to go. 4 of them are north, and 5 of them are east. 9 factorial divided by 4 factorial. 5 factorial. 126 different paths. It would take a long time to calculate or to do it every single time, because as soon as you make one change, instead of doing this one, you go here, but you go over one more instead. That's a completely different path technically. We'll keep on going. This one's gonna kind of tie into the Canada question. How many ways can the words banana how can all the letters of the word banana be arranged if there's no restrictions? Well, we have 3 A's and 2 N's. There's 6 total letters, so 3 factorial, 2 factorial. Factorial divided by 3 factorial, 2 factorial. 60 different ways. It'll take a while for you to do it, but you could do it. And what about if the arrangement has to start with a B? Well, the rest of it, we'd have 5 letters left. But all of those repetitions, the 3 A's and the 2 N's, are still not being used. So that's not going to change anything. At least on the repetition side. But taking out that B eliminates all the other options. So there'd be 10. So what that's saying is, of these 60, 10 of them start with just B. The other 50 would have to start with an A or an N. Kind of makes sense if you have 6 letters. Kind of works. The arrangement must start with an A. So if the first letter has to be an A, there'd still be 5 letters left. But the difference is there'd be different repetition left. There'd only be 2 A's left, but there'd still be the 2 N's. And 30 of them, 30 of the answers, 30 of the 60 would start with an A. Because it doesn't matter whether you start with This first A, the second A, or third A, they're all identical. That would be a completely different question if this was like the purple A, the red A, or the green A. Those are completely different options. So I'm just going to take those off there. And then what about the arrangement must start and end with an A? So it has to start with an A and has to end with an A. It doesn't matter whether, because these are identical A's, it doesn't matter whether this is the A that's in first, this is the A. No, it doesn't really matter. There'd still be 4 letters left. There would be the B, 1 A, and 2 N's. So there'd only be 2 N's left as the repetition. So that's once again saying, of these 30, 12 of them would also end in an A. Of the 60, 12 of them would start with an A and end with an A. All right. Last one, make it quick and easy. Talk about prayer flags and talk about how different arrangements can talk about different prayers. Basically, if you arrange these colors, green, yellow, white, blue, and red, according to the country, they have different prayers that are made from them. So Dorsey wants to make a 9-flag prayer. 1 has to be green, 1 yellow, 2 white, 3 blue, and 2 red. 9 factorial over. You don't really need the 1 factorial. You can absolutely have it. Didn't talk about it before, but you can have it, but you don't need it. Because we really only care about the ones that actually have more than 1. That would be all 9. And where's my stuff? 2 factorial, 3 factorial, 2 factorial. 15,120. All right. That allows you to go have some fun.